Hey there, and welcome to this explainer. I'm super excited to dive into the heavy-duty and, honestly, pretty fascinating world of industrial metal bending with you today. You know, if you've ever looked at a perfectly curved handrail, or maybe the crisp, sharp angles of an electrical box, or even those massive structural beams holding up a bridge and thought, wait, how on earth did they force flat, rigid metal into that exact shape without snapping it in half? Well, you are in the exact right place. Today, we're unpacking the whole shebang, the equipment, the mechanics, and the strategic decisions behind this totally essential manufacturing process.
But first, why are we focusing on this right now? Well, the automated bending equipment sector is going through a massive shift. Back in 2022, this market was valued at around $2.17 billion. And get this, it's projected to surge to $3.37 billion by 2032. So what's driving that explosion? It's because modern fabrication shops are under extreme pressure. They need things done faster, they need tighter repeatability, and absolutely crucially, they need lower scrap rates. As we're going to see, the newest machines are stepping up to meet that exact demand.
Okay, so here's our roadmap for the explainer. 1. The art of metal bending. 2. Anatomy of a bend. 3. 7 types of bending machines. 4. Power versus precision control. And finally, 5. Choosing the right machine.
All right, let's jump right into Section 1, the art of metal bending.
Okay, so it all boils down to this one absolutely crucial physical principle: controlled plastic deformation. When someone asks you how a metal bending machine actually works, this is the magic phrase. Basically, the machine has to apply just enough force to push the material past its yield point. That's the exact threshold where the metal stops just, flexing elastically and instead permanently deforms into the specific angle or curve we want. This insanely precise application of force is literally what lets manufacturers take raw sheet metal, structural profiles, or pipes and turn them into everything from airplane fuselages to heavy-duty mounting brackets.
Now, obviously, we didn't start out with lasers and touchscreens. If we look back to around 1875, workshops were relying on basic folding benches. We're talking simple mechanical leverage and just a whole lot of human muscle. Fast forward to the late 1800s, and the introduction of hydraulic cylinders gave these machines a massive boost in pure force, definitely saving a lot of operators' backs in the process. But the real game changer? That hit in the 1980s and 90s when computer numerical control, or CNC press brakes, became the industry standard. And today, we're looking at fully automated sensor-assisted systems that literally adjust to the metal's properties in real time. It's wild.
Moving on to Section 2, Anatomy of a Bend. Let's look at the micro-level physics. All right, it is time to meet the primary antagonist of our story: springback. Because metal has a natural elasticity to it, it really wants to just snap back to its original flat shape the second you take the bending force away. This elastic recovery is basically the ultimate villain that machine operators have to battle all day, every day. Think about it. To get a perfect 90-degree angle, a machine might actually have to push the metal to 88 degrees, fully anticipating that it's going to spring back those final 2 degrees. Managing that natural bounce back requires incredible precision, whether that's from highly skilled operators, specialized tooling, or some seriously smart CNC compensation.
So, to fight that springback and actually control the metal, machines rely on a highly specialized tooling ecosystem. Let's break down the cast of characters here, looking specifically at tube bending. First up, the bend die, which shapes the actual radius of your curve. Then you have the clamp die. This acts as the grip, holding the tube super tightly against the bend die so there's absolutely no slipping. Next is the wiper die, which sits right behind the bend to stop the inside of the curve from wrinkling up under all that compression. And finally, the mandrel. Guys, this one is absolutely crucial, especially for tight curves and thin walls. The mandrel actually goes inside the hollow tube during the bend to prevent the whole thing from just collapsing or flattening out like a pancake.
And that brings us to the final piece of the tooling puzzle, the pressure die. I love how the source material describes this. It says, think of it as a steady hand that keeps the material moving smoothly instead of dragging or twisting. Isn't that a great image? The pressure die doesn't dictate the radius itself, but it makes sure the straight section of the metal follows the contour completely evenly. It's just a really great reminder that industrial bending isn't just about applying brute force, it's all about highly guided mechanical finesse.
Let's zoom out a bit for Section 3, 7 types of bending machines.
Okay, so let's look at the 7 main players out there on the modern shop floor. The press brake is your absolute go-to for straight-line bends on bulk sheet metal. Then, sheet metal benders step in to handle those longer, larger profiles. Pipe benders, well, those are exactly what they sound like, dedicated to hollow tubes. Plate rollers take fixed steel and roll it into big cylinders. Profile benders are the heavy lifters, taking on structural I-beams and heavy channels. CNC wire benders rapidly form 2D and 3D shapes like springs. And finally, the panel bender, which uses this really cool automated folding action that's just perfect for high-volume enclosures and cabinets.
Let's quickly contrast two of the most dominant machines on that list so you can see exactly how their applications differ. The press brake works by driving a punch straight down into a V-die, so it creates localized, straight-line, crisp angles. Think mounting brackets or square ductwork. On the flip side, you have the plate rolling machine. This feeds heavy, flat plate through a set of adjustable rollers. So instead of one localized bend, it's creating a continuous curvature. Basically, if you're building an angular electrical cabinet, you're going to use a press brake. But if you're building a massive cylindrical pressure vessel or a grain silo, you absolutely need a plate roller.
Which brings us to Section 4, Power versus Precision Control, the ultimate showdown.
This comparison is essentially the classic battle between fluid brawn and programmable digital brain. Hydraulic bending machines run on fluid power. They deliver massive, massive force. They usually have a much lower upfront cost, and they offer tons of flexibility for job shops that are tackling varied, low-volume repairs. But they do require a lot more manual adjustment from the operator. CNC bending machines, on the other hand, use digital brains. We're talking motorized axes, programmed sequences you can recall instantly, and automatic springback compensation. Now, they are definitely going to cost you significantly more upfront, but for high-volume, repetitive jobs, they are completely unbeatable simply because they drastically cut down on setup time and basically eliminate operator error.
All right, let's get practical with Section 5, choosing the right machine.
It's probably the single most critical question in fabrication, right? How do you actually choose the right metal bender for your specific workshop? The golden rule here is that the buying process has to start with the part you are trying to make, not just flipping through a glossy equipment catalog. Let's break down the actionable steps to actually make this decision.
Walk through this sequence with me. Step 1. Define your material and its maximum thickness. Metals like mild steel, aluminum, and titanium all behave super differently. And here's a massive warning from the experts. Always, always size your machine for the worst, toughest realistic job you're gonna encounter, not just your easiest part. Step 2. Determine your production volume. If you're doing high volume, repeat orders all day long, go ahead and invest in CNC automation. But if you're doing custom, one-off repairs, a hydraulic system might actually be the better bet. And Step 3. Check your floor space. Seriously, these machines need massive clearance around them. And of course, look at the total budget, factoring in not just the sticker price, but installation and long-term maintenance too.
And hey, speaking of maintenance, a machine is really only as good as how well it's treated. Safety and upkeep, totally non-negotiable. Operators absolutely must use pinch point guards and wear the right PPE. But looking at it from a quality perspective, you've got to inspect your dies for wear and cracks constantly. Worn dies are going to cause part defects way before the machine itself ever breaks down. You got to lubricate those mandrels, check hydraulic fluids every single week, and constantly recalibrate your CNC backstops. Because remember, buying a cheaper machine but settling for poor tooling or terrible maintenance habits is absolutely going to cost you way more money per part in the long run. The scrap metal and rework alone will eat you alive.
Which really leads us to our final thought for this explainer. How does matching the right machine to your exact part mix protect your long-term profit margins? Well, it's actually pretty simple. By reducing material scrap, slashing those long setup times, and eliminating rework, the right bending machine doesn't just form metal. It literally secures the financial future of your entire workshop. So what's your next big project? And do you have the exact right machine to conquer it?